Welcome to Creation Magazine Live. This is a program where we take articles from Creation Magazine and go over some of the highlights in them and encourage you to get to our website, creation.com, where many of these are archived and you can find a wealth of other information on this topic and all topics relating to the creation evolution debate and the book of Genesis.
A lot more details than we can do here.
Yes.
But the magazine covers a wide range of topics, both theological, the accuracy of the Bible, apologetics, a lot of that in there. And also, as I said before, real technical term, science-y stuff. And so here's some more science-y
stuff. Oh, yeah.
This happens to be astronomy. An article called Bye-Bye Big Bang by Dr. John Hartnett. Now, John Hartnett is a cosmologist. This guy was on staff with our Australian office. He still does some speaking for us, and he wrote a book a number of years ago, which is just amazing.
Starlight Time and the New Physics.
That's the one. Yeah, Starlight Time and the New Physics.
And well, I actually I roomed at a conference with John, and as I mentioned, I probably talked to him for about 20 minutes because when I asked him questions to do with this kind of stuff and physics and all this stuff, I don't know, my eyes just glazed over. So this is a man that's well studied in his field.
Yeah, we all have our. I like geology. You're more of a DNA and biology guy, but astronomy. Who really understands astronomy?
Well, you got to understand mathematics and physics and all that good stuff.
Here's what Dr. Hartnett says. He's a real astrophysicist. We'll just listen to him instead of us.
Yep.
A quasar with an enormous redshift has been found embedded in a nearby spiral galaxy with a much lower redshift. This changes the whole view of the universe. Big Bang astronomy will never be the same. Why should this be so?
Well, maybe we should talk about what redshift is.
He's going to get to that in the article here. But he starts off with these terms.
Because he might just assume that we know that.
Redshift. Okay, no, that's explained here.
Okay.
Quirky quasars, this next section. There are certain objects we call quasars, or quasi-stellar objects, QSOs, quasars, that have enormous redshifts. And it says here, see the box for an explanation of redshift. There's a breakout box on this in this article here that explains that further. We're not going to take the time here. Just go to the website and you can read that there. So by standard redshift interpretation, they are supposed to be at the very edge of the visible universe. So the greater the redshift, the further things are away. It's a measure of distance.
Right.
That's generally how it's understood. To appear so bright at such enormous distances, they are speculated to be superluminous black holes with 1 million or 100 million times more mass than our sun, surrounded by a disk of material. Some of the material falls into the black hole, causing the emission of huge amounts of energy, and that's what's being recorded in the telescopes.
Right.
Now, here's another heading in the article, Quasar Embedded in Nearby Galaxy. A team of astronomers / astrophysicists, including Jeffrey Burbridge and Halton Arp, published the discovery of a new quasar in the Astrophysical Journal. The enigma of this quasar is that it is embedded in a galaxy, NGC 7319, very close to its center. See Figure 2. And if you're looking at the article there, you can see the picture of this galaxy. The article's title is, Can a Distant Quasar Lie Within a Nearby Galaxy? Asked University of California, San Diego webpage that announced the discovery. According to Hubble law, the galaxy NGC 7319 with a redshift of 0.022 is about 360 million light years from Earth. But since the quasar has 100 times the galaxy's redshift, it must be receding at about 100 times faster and be 30 times farther away. Therefore, these objects could not be physically connected to each other if this was true.
Right.
So here we have the problem. This quasar seems to be associated with this galaxy. Big Bang theorists assert that the objects merely look close because the quasar happens to be in the same line of sight as the galaxy, although billions of light years behind.
Right.
So they're actually not together. They're a long ways apart. However, Arp has made a very strong case that quasars that lie close to active galaxies are physically associated with those galaxies. He and others contend that the quasars have been ejected from the hearts of their parent galaxies. The newly discovered quasar is not accidentally aligned due to a projection effect because it is seen to be interacting with the gaseous material in its host galaxies.
Right.
In its host galaxy. A very strong outflow of gas is detected consistent with the ejecting of a quasar carrying material with it. So this quasar is being ejected from the galaxy, and there's material that's following it out of the galaxy. So why do Big Bang theorists vigorously reject ARP's interpretation that quasars were ejected from galaxies, although it is based on observation? Good question. Because it utterly demolishes their key assumption of how matter first formed in the Big Bang. It also calls into question many distances determined by quasar redshifts. In his section, Alternatives to the Big Bang, in his book, Professor Joseph Silk admits, only, quote, only by disputing the interpretation of quasar redshifts as a cosmological distance indicator can this conclusion be avoided, end quote.
Right.
This is, in fact, the main thrust of ARP's observations. They cast enormous doubt on the distribution of galaxies in the universe and the interpretation of the Big Bang expansion models. However, the observations do fit with the recent creationist models for the origin of heavenly bodies. In this model, and Dr. Harton is talking about his own model here, in this model, the quasars were ejected from active galaxies in the grand creation process, and that we are now seeing through high-powered telescopes the creation process of day 4 of creation week.
Right.
This is mind-blowing stuff. As we're looking through these telescopes, we are, in a sense, looking back in time. It's taken a long time for that light from those objects way out there to get to Earth.
Right.
And so what we're now seeing are God's activities on day 4 of creation. That is
mind-blowing stuff.
That's one of the conclusions of Hartnett's model. There's many, many more details, of course, than we can talk about, but fascinating stuff.
So one of the big problems for the Big Bangers up here is when they're seeing this quasar ejected from this galaxy, so am I getting this correctly? They're saying, well, that can't be because they don't want to believe that that's a process that would create that.
The galaxy and the quasar that seems to be associated with it have such dramatically different redshifts.
Right.
And redshifts have been interpreted as, or can be understood as a measure of distance.
Right.
The higher the redshift, the further the thing is away, and the faster it's moving away from
But because those two things are so contradictory, then you'd have to get rid of the notion that those redshifts then are associated with.
Exactly.
Right.
And if you get rid of that, the Big Bang falls apart. That is a fundamental assumption in the Big Bang,
right,
that the objects with very high redshift are further away from us and they're moving away from us faster than objects that are closer.
Right.
Okay, so the objects do fit this new model. The quasars were ejected from active galaxies, and so we're seeing the creative acts of day 4. This model overturns the usual interpretation of redshifts. That is, quasar redshift distances are not cosmological. That is, caused by cosmos receding at huge distances, but instead are intrinsic, something caused within the quasar itself. So the redshift is being generated by that object itself.
Right.
In this new model, though day 4 lasted only 24 hours by Earth clocks, one Earth rotation in any case, it might have lasted a long time in cosmological years, i.e. as measured by cosmological clocks. It's just a weird fact that Einstein's relativity, that time can run differently for different observers in different locations and times.
And that's a big part of John's model, talking about time dilation.
It's talking about relativity, yes. Yep. And the article goes on here to talk about relativity and many other things. There's a lot more that could be said about this. You can go to creation.com to discover those things.